So in this video, we're going to talk about how to factor out a GCF from a polynomial. So remember that factoring is basically multiplication backwards. So when we write a polynomial as the product of its factors, we're saying that multiplying the factors together will give us the original polynomial. And this is also a really great way to check your answer. So for example, if we want to verify that the factors of 3x squared minus 12x plus 6 are 3 and x squared minus 4x plus 2, I'm just going to multiply 3 times x squared minus 4x plus 2. So remember, when I do that, I'm going to distribute the 3 to every term. And so that's going to give me 3x squared minus 12x plus 6. So you can see that this does match the original polynomial, so I know that I've factored correctly. So the greatest common factor of two or more expressions will be the largest factor that will evenly divide all expressions. So remember, when you work with algebraic expressions, your GCF could be a number and a variable raised to an exponent. So for example, if we look at 3x squared and 18x to the fourth, the GCF will be 3x squared because I can evenly divide both of these terms by 3x squared. So when we want to determine a GCF, we are just going to look at the numerical part and the variables. So for example, suppose we want to find the GCF of 21x cubed and 9x squared. So I'm going to break this apart. I'm going to look at the 21 and the x cubed separately. So when I divide out 21, I want to think about factors that 21 and 9 have in common. Okay, so when I think about that, I know that both are divisible by 3, so I'm going to rewrite this 21 as 3 times 7. And then remember, x cubed is basically telling me that I have x by itself 3 times, okay? So what I'm going to do now is break apart the 9x squared in a similar way. So that's going to give me 9 and then x squared. So the 9 is going to be 3 times 3, and then x squared is just x times itself twice. So now I'm going to look at the common factors I have between these two expressions. So notice that I have a 3 in both, and I have an x in both, and I have another x in both. Okay, so all those common factors that I circled now, I'm going to multiply together. So I have 3 times x, and that gives me 3x squared. So 3x squared will be the GCF of these two expressions. Remind you of this important property of exponents that we talked about in the properties of exponents video. When we're dividing terms with the same base, the exponents are subtracted. So remember, we said a to the m over a to the n equals a to the m minus n. So here's an example. If we have x to the fifth over x squared, that's going to be x to the 5 minus 2, which is equal to x to the third. So that's how you find the quotient of powers. So here's an important warning just to keep in mind when we're working with terms that have coefficients and variables with exponents. When you're working on these problems, remember to work with the coefficients separately from the variables, because the coefficients will follow the standard rules of multiplication, division, whatever we're doing, but the exponents will follow those special rules. So for example, suppose we were dividing these two monomials. So we have 16x to the 7th, y to the 9th over 4xy squared. So remember, what we did is we broke this apart. So I took like 16 over 4, and then I did x to the 7th over x, which is like x to the 1. And then we did y to the 9th over y squared. Okay, so the 16 divided by 4, that's where we're going to have the normal rules of division, right? So we're just going to do 16 divided by 4, which is 4. The x to the 7th over x to the 1, that's where we use that exponent property. So that's going to be x to the 7 minus 1. Same thing with y. We have to use that exponent property with y, so we have y to the 9 minus 2. So when we write this final expression, this is going to be 4 x to the 6th, y to the 7th. Okay, so that's how you use those properties separately for variables, and then you use regular division for the coefficients. So when we're factoring a polynomial using the GCF, we're going to start off by determining the GCF of all terms in the polynomial. Then what you're going to do is you're going to divide every term in the polynomial by the GCF. So that's why we were reviewing those division rules. Then we'll write the polynomial as the product of the GCF in the factored expression. So let's try now this example. So you can see here we have 18x to the 4th minus 21x cubed. So the first task is going to be to look at these two terms and determine the GCF. Well, let's think about what's the biggest number that will evenly divide both 18 and 21. That's going to be 3. So now we want to think about the variables. So if you want, you can draw out the factor trees like I did on those first examples. But once you start to do more of these, you'll start to kind of see patterns. When you're pulling out variables, you're going to look for the common variables that the terms have. So in this case, both terms have an x. To determine the exponent of x, you just need to look at the lowest exponent of x in any term in the problem. So for example, between 4 and 3, the lower exponent is 3, so that means I can at most pull out x cubed from both of these terms. So what I'm going to do now is when I factor out a GCF, I'm going to put that GCF in front, and then I'm going to divide both terms in this by that GCF. Okay, so 18x to the 4th over 3x cubed minus 21x cubed over 3x cubed. Okay, so we leave that 3x cubed in front, and now we simplify what we have on the inside. So that's where those division properties come into play. So we have 18 over 3, just regular division there, and we have 6. X to the 4th over x to the 3rd, we need to subtract the exponents, so that just gives us an x to the 1. Now let's go to the second term. 21 divided by 3 gives us 7, okay? X cubed over x cubed, well, that's like x to the 3 minus 3, so that's going to be x to the 0, okay? So let's write this a little bit better. So we have 3x cubed times 6x, because remember, we usually don't write exponents of 1. And then minus, well, remember what x to the 0 is? Anything to the 0 power is 1. So what I've written here is basically like 7 times 1, which is just equal to 7. So I don't need to write that x to the 0. I can just write this as 6x minus 7. So this is how you factor that expression using a GCF. So now let's try this example. Here we have 3 terms, so when we're figuring out the GCF, it needs to be common to all 3 terms. So I'm going to look at 12, 24, and 20 and think about what's the biggest number that will evenly divide all of these terms. And that number is 4. Okay, now notice that all of my terms have an x in them. So I'm going to think about what's the smallest exponent on x. The smallest exponent is 3, so my GCF will be 4x cubed. So now I'm going to factor it out, and I'm going to divide every single term in this expression by that GCF. And so let's go ahead and do that. 24x to the 4th over 4x cubed minus 20x cubed over 4x cubed. So that gives me 4x cubed. Remember, I have to leave my GCF in front. And then 12 divided by 4 is 3. X to the 5th over x cubed gives me x squared. Plus 24 divided by 4 is 6. X to the 4th over x to the 3rd is going to be x to the 1 that I can just write as an x. And then minus 20 over 4 is 5. X cubed over x cubed, those two terms will just cancel, or you can think about it as x to the 0, which is just 1. So this is going to be the fully factored form of this expression. So now you can go ahead and pause the video and try doing this example on your own. So here notice that all 3 coefficients have a common factor of 5, and then all these terms have an x in them, so I can pull out an x, and the lowest exponent on x is going to be 3. So I can factor out a 5x cubed, and when I do that, that gives me 5x cubed times 4x squared plus 6x minus 3.